Good afternoon, folks. Today's topic A is about microplastics in the brains of people with dementia. So we're going to discuss that for A. So please join me for the presentation I made. Please sit back and enjoy. Here we go. High levels of microplastics have been found in the brains of people with dementia, and multiple recent studies suggest this may be an emerging environmental risk factor for neurodegeneration. The evidence does not yet prove causation, but the correlation is strong enough that scientists are calling for urgent investigation. What the new study found: people diagnosed with dementia had significantly higher concentrations of microplastics in their brain tissue compared to non-dementia controls. An average human brain may contain up to 7 grams of microplastics. Roughly the weight of a plastic spoon. Microplastics were found not only in the brain tissue but also embedded in cerebral vascular walls and immune cells, with even greater accumulation in individuals with documented dementia. Dysfunction. All known pathways in Alzheimer's and Parkinson's disease promote aggression of amyloid uh, 3 tau and a synuclear proteins central to major dementias, potentially disrupt the gut-brain axis, amplifying systematic inflammation and neurodegeneration. Broader context: microplastics are rising in human brains. Microplastic levels in human brain tissue have increased by 50% between 2016 and 2024. Brains contain 7 to 30 plus more microplastics than liver or kidney tissue from the same individuals. Polythyrene is the most common polymer found in human brain samples. Does this mean microplastics cause dementia? Not yet, scientists emphasize. The studies show correlation, not proven causation. However, the dose dependent relationship, more microplastics equals more dementia cases, is raising concern. The biological mechanism linking plastics to neurodegeneration are plausible and increasingly supported by lab and animal data. Why this matters? Microplastics are now found in food and water, air, human blood, placenta, arterial plaques, brain tissue. Their presence in the brain, especially in higher amounts in dementia patients. Suggest a potential new environmental risk factor for cognitive decline. Ways to reduce personal microplastic intake. New studies show people with dementia have higher concentrations of microplastics in the brain tissue. But current evidence demonstrates correlation and plausible biological mechanisms rather than proven causation. Summary of evidence. Human autopsy work found microplastics and nanoplastics in brain tissue, with brains showing higher concentrations than liver or kidney and rising levels over time. Decedent brains from people with documented dementia carried the heaviest microplastic loads and showed deposition in cerebrovascular walls and immune cells. A recent mini review synthesizes mechanistic and epidemiology signals link chronic microplastic exposure to neurodegenerative processes. How microplastics could plausibly affect the brain. Crossing barriers, animals and in vitro studies show nanoscale plastic can cross the gut and blood-brain barriers within hours, enabling direct brain exposure. Toxic pathways. Microplastics can trigger oxidative stress, chronic neural inflammation, mitochondrial dysfunction, and carry absorbed pollutants of metals that amplify neurotoxicity pathways implicated in Alzheimer's and other dementias. Protein aggression. Laboratory data suggest plastics may accelerate aggression of amyloid B and tau peptides, a core feature of Alzheimer's pathology. Mechanistic evidence still emerging. What the findings do and do not show do provide consistent reproducible detection of microplastics in human brains, and a dose accelerated pattern, higher loads in dementia cases that raises concern. Do not establish that microplastics cause dementia in humans. Observational autopsy data cannot exclude reverse causation, confounding diet, comorbidities, environmental exposures to post-mortem contamination without larger perspective studies. Practical steps to reduce personal exposure. Reduce intake of ultra-processed and packaged foods, and favor whole foods to lower ingestion from packaging. Minimize airborne exposure by improving indoor ventilation, using HEPA filtration, and avoiding synthetic textiles that shred fibers. Limit heating food in plastic containers, and prefer glass or stainless steel for storage and refrigeration or reheating. Research gaps and next steps needed. Large prospective cohorts, measuring exposure, standardized tissue levels, assay dose response thresholds, and interventional trials to test whether exposure reduction changes biomarkers or clinical outcomes. The bottom line: the association between brain microplastics and dementia is an important emerging signal backed by tissue detection and plausible mechanisms that casualty is unproven. Reducing avoidable exposure is a reasonable precaution, while stronger epidemiology and mechanics work. Proceeded. Okay, guys, that's A for you. I will be back on with B shortly. Give me a bit for a little break, and I'll be back with you for B. For now, Gator Wellness. Take care, folks.